In this segment, we will look at a review of Pythagoras' theorem. Now, as with every topic in math, there is application of principles, and you would have gone through Pythagoras' theorem before, but this question demonstrates a practical application of the topic. It says, to get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south and 41 meters east. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? So let us review a little bit what we know about triangles, in particular right triangles. Now, a triangle is a polygon that has 3 sides. A right triangle is a 3-sided polygon that has one of its angles measuring 90 degrees. And because it measures 90 degrees, it is called a right angle, and therefore the triangle is called a right triangle or a right angled triangle. Now, in a right triangle, the side that is opposite to the right angle has a special name. It is called the hypotenuse of the triangle, and it is also the longest side of the right triangle. So as is stated here, Pythagoras' theorem is a tool for right triangle problems only, and it is used to find the lengths of sides. So the question is, when do we need to use Pythagoras' theorem? Well, we will use Pythagoras' theorem when we have the length of 2 sides and we need to find the length of the 3rd side. You may recall this simple formula that is used for Pythagoras' theorem. So we have a squared plus b squared is equal to c squared, where a and b are the legs of the right triangle and c is the hypotenuse. So essentially then, Pythagoras' theorem states that the square of the longest side of the right triangle is equal to the sum of the squares of the other 2 sides. The theorem can be transposed to find the formula for each side of the right triangle. So if we're talking about the hypotenuse, which is represented by c, and we're trying to find the length of the hypotenuse, then the formula can be rearranged as c is equal to the square root of a squared plus b squared. If we're talking about one of the other 2 sides labeled a, then a is equal to the square root of c squared minus b squared. If we're talking about the other side labeled b, then b is equal to the square root of c squared minus a squared. So let us revisit our application question, and based on the triangle that we were able to sketch, we recognize that the distance that we need to find is the distance AB, which is the hypotenuse of the right triangle. So the version of the formula that we're going to use is c is equal to the square root of a squared plus b squared. In this case, we're assigning a to the value 34 and b to the value 41. And so we continue with our calculations and simplifying. Having found the square root of the sum, the length of c, which is our hypotenuse, is 53.26 meters.